This is Learning Assessment Problem 217. In this problem, we're asked to determine the value of a voltage VO, which appears across one of the resistors in the circuit. The problem-solving strategy here might be analyzing circuits containing a single source and a network of resistors. In order to determine that voltage VO, we might apply the tools which we have available are Ohm's law, the two Kirchhoff's laws, voltage division, and current division. In order to determine that voltage VO, we might apply voltage division or use Ohm's law with respect to a current IO flowing through the 20K resistor. We'll try that latter approach. So our first step is going to be to try to reduce the resistor network to a single equivalent resistance connected to the 12-volt source. We notice that we have two resistors in series, so we could say that RS1 is equal to 40K plus 20K, and that's equal to 60K. Now we can take that equivalent resistance for those two series resistances, place them, and place the equivalent RS1 60K in the circuit. Now we see that we have two resistors in parallel, and RP1 now, as that combination, is equal to 30K in parallel with 60K. It's equal to 30K times 60K divided by the sum 30K plus 60K, and RP1 is equal to 20K. In the next stage of the reduction, we'll place that RP1 in the circuit. And now we see that we have two resistors in series, equal value 20K, so we'll call that RS2 is equal to 20K plus 20K, or RS2 is equal to 40K. Now we can place that resistance, RS2, across the 12-volt source. And now we're able to calculate the current I1 flowing from the source. So by Ohm's law, I1 will be 12 volts divided by 40K, or I1 is equal to 0.3 milliamp. So now we've established the value of the I1 in the circuit. Again, we're trying to find the value of I0 flowing through the 20K resistor so that we can eventually use Ohm's law to predict the voltage V0. So by current division, for the I0 current, we have that is equal to I1 times the resistance in the other parallel branch, which is 30K, divided by the sum of the resistances, 30K plus 40K in series with 20K, and I0 is 1/3 value of I1, which is 1/3 times 0.3 milliamps, or I0 is equal to 1/10 of a milliamp. And finally, we're in a position to calculate the desired voltage VO. Portion of the circuit is shown here. We have 40K, 20K, and that IO current flows down through the 20K resistor, and we are looking for the voltage across that resistor. So by Ohm's law, VO is equal to IO times 20K. That's equal to 0.1 milliamp times 20K, or VO is equal to 2 volts.